This question is sketch A, 3 plus tan 2t, and B, 2 minus sine t on 2. So as usual, because it says sketch, I could get my computer to draw it and copy those answers down as my answer. Here is what my computer does when I ask it to draw tan t. This is one of the asymptotes at pi on 2, and this is minus pi on 2, another asymptote. 3 pi on 2 minus 3 pi on 2 and so on. It crosses the x and the y-axis, the t and the y-axis just here at the origin, and again at pi and 2 pi and minus 2 pi. So that's tan t. Up here in the corner there's a slider. At the moment it says 1 because we have tan 1t on the picture. I can drag this to make it into tan 2t, and you watch what happens. My function shrank inwards towards the y-axis. So this is what it looked like before, and now it shrinks inwards. Because I multiplied that t inside the bracket, that 2 inside the brackets next to the t, it shrank my function inwards by half. That's what happens when you do things inside the brackets. The opposite happens to the function. So here's tan 2t. Well, actually we have 0 plus tan 2t. If I drag this one, it will turn it into 3 plus tan 2t. And you can see that it went upwards 3. Instead of crossing here at 0, it now crosses here at 3. So that's now 3 plus tan 2t. Let's have a look at sine. Here's y equals sine t. You can see it crosses here at 0, 0 and goes up as we go to the right, reaches its highest point at pi on 2, comes back down, crosses at pi, reaches its lowest point, which is minus 1, here at 3 pi and 2, and then comes up again and crosses at 2 pi, and does the opposite over here on the left-hand side. We have 3 sliders here. The first one is because we have, at the moment, sine 1t, and I actually want sine half of t. So as I drag that to a half, the function stretched outwards. We did the opposite. Instead of dividing by 2, we multiplied by 2. This 1 here is because we have 1 sine t on 2, but I want minus 1. So as I drag that down, my function flipped over. It was here, going upwards first as you went to the right, and now it goes downwards first as you go to the right. But in all other respects, it's exactly the same. And this last one is for that too. So now we have minus sine t on 2, and as I drag this, it becomes 2 minus sine t on 2. So because we added on a 2 at the front there, the whole function shifted up. So instead of crossing at 0, it now crosses at 2. Now of course, you can't always have fancy interactive computer programs with sliders, so you should be able to figure this out by hand. And so I'll show you the best way to do that without it becoming extremely messy. So let's do the tan first. A. I'll draw my t-axis and my y-axis. Now, tan crosses at 0 and, well, let's just remind ourselves where tan crosses. 0 and pi and 2 pi, and it has asymptotes at pi on 2 and 3 pi on 2. So tan 2t will be half as wide. So instead of having an asymptote at pi on 2, it will have an asymptote at pi on 4. And at minus pi on 4. And instead of crossing the x-axis, instead of crossing the x-axis or the t-axis at pi, it will cross at pi on 2. And down here at minus pi on 2. So everything's half as wide. So that's 3 pi on 4, and there's another one down here at minus 3 pi on 4. Okay? Now normally, tan 2t would cross the y-axis here at 0, but it doesn't because we've added on an extra 3, so the whole thing shifts up 3. So instead of it doing all of this here on the t-axis, it's going to do it here at y equals 3. So now we can draw our graph. And it will continue outwards in that fashion. So this is my graph of y equals 3 plus tan 2t. Okay, so let's do part B now. So here's my t-axis, and here's my y-axis. Now, sine normally starts at 0 and comes up as you go to the right and comes down again and crosses at pi. But it's now, because we've multiplied, because we've got sine half of t, the whole thing stretched outwards by 2. So instead of reaching its highest point at pi on 2, it's going to reach its highest point at pi. And then it's going to come back down again and cross at 2 pi, and then it's going to reach its lowest point at 3 pi instead of at 3 pi on 2. And similarly in the other direction. And also, sine went upwards when you went to the right, minus sine t on 2 is going to go downwards because it goes in the opposite direction. And finally, it's not going to do any of this here at the t-axis because we've added on a 2, so the entire graph is shifted upwards to do all of this stuff that it did on the t-axis. It will do it on the line y equals 2 instead. So here's 1, 2, 3, and there's y equals 2. So it's going to come downwards instead of upwards, reach its lowest point at pi, and that lowest point would be minus 1 because it only goes down 1, and come up again and cross here at 2 pi and come up again and continue in that fashion. And then so it will do it this way over here and do that. So we have y equals 2 minus sine t on 2. And we've sketched both of the graphs, so that's the end of the question.